Good evening, everyone. Welcome to NPTEL tutorial session for the course Classics in Total Synthesis taken by Professor Krishna P. Kaliappan from IIT Bombay. I am Sri Lakshmi S, a PhD scholar in Department of Chemistry in IIT Bombay. So this is our fifth tutorial session. So far, we have seen the up to week 4 lectures, and we had a discussion on what all are the topics covered until week 4, and we have also discussed week 0, week 1, week 2 assignments as well. So today in this session, firstly we will see some questions related to the topics which we previously discussed already, and then we will move ahead with the discussion of week 5 lectures as well as week 3 assignment also. Maybe before that we will wait for a couple of minutes to see anyone else is joining, then we will start our class. Okay, so in the last class, we stopped here with this question, the mechanisms for the formation of molecules A and B involved. So, here two reaction pathways are given with this compound. So, firstly, this compound is treated photochemically under light, it is giving this compound B. And when we are using a sensitizer along with the photochemical condition, we are getting this compound A. So we have to identify which are these reactions which leads to these products A and B. So the four options given are oxidipymethane rearrangement and Norrish type 2 cleavage. Option 2 is Norrish type 1 cleavage and oxidipymethane rearrangement. Option 3 is oxidipymethane rearrangement and Norrish type 1 cleavage. Option 4 is Norrish type 1 cleavage and Norrish type 2 cleavage. We have already discussed it in the last class, but we will start with here so that you can quickly go through what we discussed in the last class. So, which will be the correct option here? So here we will see the answer. The first option is like for the product A, we are using H nu and sensitizer. So what is happening? This bond is cleaving and this bond is cleaving homolytically, generating this radical. Then this two radical will combine to form the cyclopropane ring. Either this bond will break to form this double bond O, and this two will combine to form this compound A. So this is an example of oxidipymethane rearrangement. We have seen previously the examples as well as detailed mechanism of this oxidipymethane rearrangement. Now, if we are not using any sensitizer and only photochemical condition, it is cleaving this alpha bond to this carbonyl. So it is forming like this. Then this double bond is shifting to here, creating a radical at this position. Then these two radicals are combining to form this compound B. So this is an example for Norrish type 1 cleavage. So the correct answer is oxidipymethane rearrangement and Norrish type 1 cleavage, option 3. Now moving to the next question, the major product formed in the following reaction. So here this compound is treated with TiCl3, LaAlH4 and then hydrolysis, which will be the major product here. I think this question also we have discussed last time, so I will not go into detail. 2 minutes I will give you and I will let you know the answer, then we'll move ahead with the next question. So here the correct answer is this one, option 1, and we have already seen the mechanism. This is an example of McMurray coupling. We have seen the examples as well for this question. Now moving ahead with the next question. So from here, today's session will be starting. The major product formed in the following reaction sequence. So this particular compound, upon treating with this ester with, first one product will form. Then we are heating that product greater than 200 degrees Celsius. So out of this four options given here, which will be the final product after this two steps of reaction. So I will give you a couple of minutes and then we will discuss the mechanism as well as the answer. So here, what is happening first? This Wittig reaction of stabilized halide will react upon this aldehyde, and that will give this product, which is the stable compound E isomer, which could be rewritten as this one. Then, upon heating greater than 200 degrees Celsius, this 3 3 Claisen rearrangement is taking place. So 1, 2, 3, and 1, 2, 3. So this compound will be forming. Then a 3 3 co rearrangement will take place, and this will come over here and this bond will shift over here to form this one. Then again, what is happening, to regain aromaticity, a 1 5 hydrogen shift is happening to form this aromatic compound, and then transesterification, that is this hydroxyl group can attack on this carbonyl carbon and OET will leave to form this cyclized product. So we will be getting the correct answer will be option 4. So that is the mechanism. You can go through it. First Wittig reaction, then 3 3 Claisen rearrangement, then 3 3 COP rearrangement, then 1 5 hydrogen shift and transesterification. Now, moving ahead with the next question, the major product of the following reaction. So, this oxime we are treating with H2SO4, which will be the major product out of these four options. So here what is happening, this is an example for Beckmann rearrangement. So Beckmann rearrangement is basically the acid catalyzed conversion of ketoximes to N-substituted amides in which the alkyl group attached to the carbon migrates to the nitrogen and the hydrolysis of the final products gives primary amine. And this reaction takes place in presence of Lewis acids and it is a very stereospecific reaction and the migration of the group is not decided by their migratory aptitude. So here it is what is happening. So first, this OH will get protonated by the sulfuric acid to form this compound. Then this lone pairs of nitrogen will fall here, OH2 will leave and this bond will migrate to this nitrogen and it will form this kind of intermediate. Then again water molecule will attack over this carbon and it will stabilize the positive charge on this nitrogen to form this intermediate. Then this SO3H minus will take proton to form this intermediate and again this nitrogen lone pair will take this proton and form this intermediate. Then this oxygen lone pairs will fall and this imine bond will shift to nitrogen to stabilize its positive charge to form the cyclic amide. So this is an example for Beckmann rearrangement and it is actually giving a ring expanded product which will be an amide basically. So the correct answer is option 3. So this is a new reaction which we didn't discuss in the previous sessions. This is an example for Beckmann rearrangement. Now moving ahead with the next question, the major product formed in the given reaction. So this compound here is OTF and here is C10H21 is treated with this benzaldehyde in presence of chromium chloride, nickel chloride catalytic amount DMF RT, which will be the major product in this reaction. So here this is an example for Nosaki Hiyama and Kishi reaction. So here what is happening? This is a nickel and chromium coupling reaction which will form this kind of aldehyde when we are treating it with an allyl or vinyl halide. So this is another example where this chromium salt solution prepared by the reduction of chromium chloride by lithium aluminum hydride, this benzaldehyde was added. So this is the mechanism of this reaction. So firstly this chromium chloride will undergo oxidative addition over this triplet to give this compound, then this will attack over this benzaldehyde to give this product, this alcohol. So the correct answer would be option 2, and here one oxygen is missing here also. No, the correct answer would be option 4. Yeah, here this alkene and this carbonyl is getting converted into OH. Now, the next question, the correct combination of reagents to effect the following reaction. So, as we can see here, this CHO is being reduced to this alcohol and the stereochemistry of this alcohol is changed. Here, this is beta and here it is alpha. So, which combination of reagents will give this correct product? So here what is happening, first we are treating this compound with PPH3 dead and benzoic acid, so that is the condition for Mitsunobu reaction. So that will form this inverted stereochemistry at the center and here this ester will be forming corresponding benzoate. Then when we are using LAH, this aldehyde will also get reduced, so there is a mistake here. This will be CH2OH. That aldehyde will be reduced under LAH condition and as well as this ester will also get reduced to give this OH with inverted stereochemistry as that of the starting material. So the correct combination of reaction is option 3, PPH3 dead, benzoic acid and LAH. Now moving to the next reaction, the major product formed in the following reaction sequence. So this bromo alcohol, this compound, where first we are treating with this NSNH2 dead PPH3, in the second step with cesium carbonate and tetrabutyl ammonium iodide, and in the third step with thiophenol and potassium hydroxide, which will be the major product here. So here what is happening in the first step, as we told earlier, it's a Mitsunobu reaction where this alcohol will undergo Mitsunobu reaction to form this particular product, that is this one. So you can see here what is the mechanism of Mitsunobu reaction. Since we have already discussed it earlier, I am not going into the detail. Then in the second step, the cesium carbonate and tetrabutyl ammonium iodide will take this proton of this amine, and that N minus will attack over this center and this bromide will leave to form this compound. So that can be written as this one. This TS could be TS is this functional group. Then what is happening? This SPH minus will attack over this sulfur center. This bond will go here and this bond will shift towards this nitrogen, and that will be quenched to give this NH. So the correct answer will be option 4. So that is basically Mitsunobu reaction and then cyclization, then deprotection of that tosyl group. Not tosyl, nosyl group, that is giving the product 4. Moving on with the next question. The major product formed in the following reaction sequence. So here this compound A upon treatment with tertiary butyl lithium diethyl ether at minus 78 degrees Celsius, then treating with this diiodoethane. So which will be the major product here? So here what is happening? First, tertiary butyl lithium will take the proton from the fourth position of this pyridine that is adjacent to this ether to give this lithium minus and Li plus. Then what is happening? This oxygen can coordinate with this lithium, and in the presence of this iodine, this ICH2CH2I, that iodine will come over this position to give this compound 2. So the correct answer is option 2. Now the next question, the major product formed in the following transformation. So this compound upon treatment with ferric chloride, which will be the major product. So here what is happening? This is again this example which we have seen earlier, like similar kind. So with this oxygen, this ferric chloride will coordinate, and then a rotatory ring closure will take place to form this compound, and then this will be formed when this like this positive charge on this carbon will be neutralized. So the beta silyl carbocation will be formed, and then this will eliminate, and here this positive charge will be stabilized to form this double bond. Then this will come here and this will get quenched to form this compound. So the correct answer is option 4. And the stereochemistry is controlled here by this rotatory ring closure. Now moving to the next question, the intermediate for involved in the given ITAD reaction is, so this compound upon treatment with this CrO2Cl2, we are getting this aldehyde. So this toluene is basically converted into benzaldehyde. So which is the intermediate involved in this reaction? So here what is happening is that the mechanism of the reaction goes like this. So this one of the proton will undergo in reaction, and this bond will attack over this chromium, and this oxygen will take this proton to form this intermediate. Then a 2,3 sigmatropic rearrangement is happening to give this compound. So that is the correct intermediate. So the correct answer would be option 2. This will be the intermediate. This is an in reaction followed by 2,3 sigmatropic rearrangement. Now moving ahead with the week 3 assignment. So here, which is the correct answer for this question? Identify the major product A in the following transformation. So this much was the some of the questions regarding related to the topic which we discussed in last class, that was week 4 lectures. So this is week 3 assignment. Identify the major product A in the following transformation. So this diol upon treatment with DCC, DMSO, pyridine and trifluoroacetic acid in benzene, which is the major product formed here. So here this is an example for Fitzner Moffat oxidation. So this DCC, DMSO, pyridine, TFA is the combination of reagents which is used for this Moffat oxidation, we can say. So which will be the correct answer if it's an oxidizing reagent, and try to predict the mechanism as well. So here the mechanism goes, the correct answer is option C, that is this one, and the mechanism goes like this. So first this DCC and this pyridine will react to form this intermediate, which is getting attacked with this DMSO, and it will form this compound. Then this alcohol will be attacking on the sulfur to form this particular intermediate, and this is a kind of complex mechanism, but just remember one thing, that is it is used for the oxidation of the alcohol. So here what will happen, one of the alcohol will get oxidized and the other alcohol will push it towards this double bond, and and the other alcohol is getting eliminated, so that it will result in a double bond at this position. So that is happening in this case, so the correct answer is option C. Now the next question is the major product A in the following reaction. So this nitron, upon toluene reflex condition, it will produce a compound A, so which will be that in this react in this options given below. So here what is happening, first this Like this is written in this form, and in toluene heating condition, this O minus will attack over this position, then this double bond attack over this carbon, and this bond will shift to neutralize this positive charge on nitrogen to form this compound. So that is happening reaction in this reaction, and the correct answer would be option D. Now the next question is identify the major product in the two-step reaction sequence given below. So this compound upon treatment with SOCl2 diethyl ether and the second step methanol, which will be the correct product here. So here the correct answer is this one, option A. And what is happening first with this SOCl2 and diethyl ether, it will convert this carboxylic acid into corresponding acid chloride, and in the same step this hydroxyl group also will be converted into OSOCl. Then SO2 will eliminate and Cl minus will eliminate to form this intermediate. Then to that this chloride minus will attack and this bond will open to form this compound. So the correct answer is option A. These questions is already available in the lectures and we have also seen in the discussion as well. Now the next question is identify the major product in the following transformation. This alcohol, that is an enol type of protected dienol type of compound upon treatment with NIS, that is N-iodosuccinimide, and this vinyl ether, which will be the major product here. So here the correct answer is this one, option A. And here what is happening? This first with this NIS will form iodonium ion over this vinyl ether, and this oxygen lone pairs will fall and attack over this uh, compound, and this OET will be that is this double bond will come over here to form this compound. So this iodonium ion, like I will draw it here. So here iodine with positive charge, and here OET will be there, so that OET, this oxygen lone pair will fall over here and this iodonium ion will open, and this onto that double bond this oxygen lone pair will attack and it will form this compound. So the correct answer would be option A. Now the next question is identify the major product formed in the reaction given below. So this compound upon treatment with PTSA, which will be the major product? So here the correct answer is this one, option B. And here what is happening? First, this PTSA will protonate this double bond to form this carbocation. Then this bond B will migrate to form this carbocation, and which can give rise to, when this bond will migrate to here, it can give this one. Then proton will lose and it will give this isocommine. So the correct answer would be option B. Now, the next question is, identify the starting material A involved in the following reaction. So, this starting material upon treatment with Ki, iodine, sodium bicarbonate in the first step, and then in DBU, THF condition, we will be getting this lactone with an alkene. So, which will be the corresponding starting material we would have to start with. So here the correct answer is option A. And what is happening? So when we are starting with this, first iodonium ion will form. So that will give corresponding iodonium ion over here, the sender, and then this carboxylic acid will attack over that iodonium ion and it will open. That will be the with KiI2 and NHCO3. Then in DBU THF condition, HI will eliminate and we will get this double bond over the center to get this compound given as the product. So first iodonium ion formation and then lactonization and then HI will eliminate to give the product. Now the next question, what is the major product formed in the following reaction? So this particular compound upon treatment with MCPBA and in the second step with BF3 etherate, which will be the major product forming here? So here what is happening, first MCPBA will form epoxide over the center, and then this bond will come over here, and this will open when BF33 will coordinate with this Lewis acid to give this corresponding compound. So the correct answer would be option D. First epoxidation, and then with epoxide Lewis acid will coordinate and epoxide will open and the bond migration will take place to form this 5-membered cyclopentanone ring. Now the next question is, identify the major product in the following transformation. So this particular compound upon treatment with HNU, and then this like diisopropyl, like IPR twice NMGI, which will be the major product. So that is a kind of, we can say, Grignard reagent, so which will be the major product here. So here the correct answer is option C. And what is happening first with the treatment of HNU? First, with the treatment of HNU, this 2 plus 2 cycloaddition will take place with this alkene and this ketone. So that will form this compound. Then upon this reagent addition, it will open that like we can say that furan, not furan, like that 4-membered oxetane kind of ring. 4-membered oxygen containing ring, and the double bond will form here and oxygen will be forming at this center. So it will attack at this center, like it will take proton from this, so that bond will shift to here and this will open here. So here negative charge will be, one second, here negative charge will form, it will be CH2 minus, and that would come over here, that is basically a base. So and this will open and it will become OH, so that will give this product option C. The next question, identify the correct structures of A and B in the following reaction sequence. So this alkene upon treatment with this ketene, first a compound A will form, which upon treatment with the zinc and acetic acid, this compound B will form. So which will be the corresponding A and B? So I will directly go to the answer. The correct answer is option D. And what is happening first, once this will form, this will react with this compound to form this kind of a reactive intermediate, which upon zinc acetic acid condition, this chloride will be removed and we will get this corresponding product. So the correct answer would be option D. So first is a 2 plus 2 cycloaddition, then that Cl will be eliminated to form the compound B. And the last question of week 3 assignment is identify the correct structure of the major product A in the following reaction. So this benzaldehyde and this furan derivative upon photochemical exposure, which will be the major product. So here I have given the answer, just a 2 plus 2 cycloaddition reaction is happening. It's a very straightforward question and we will be getting option B as the correct answer. So, with this, we will conclude today's session. So, week 5 lecture discussion we will continue in the next session. So, thank you for listening and thank you for joining. If you have any further queries, please do let me know. We will try to solve it in the upcoming sessions. Thank you.